You can see for biaxial interference figure, there are 5 major types: acute bisectrix figure, obtuse bisectrix figure, optic axis figure, optic normal figure, and off-centered figure. Out of these, only these two are mostly used to determine optic sign, and these are useful. These are very we are not using these 3 types, right? These are mainly used. So acute bisectrix figure means, as we have discussed, the acute bisectrix means there is 2B angle, there is formation of 2B angle, one of them will be acute, one of them will be obtuse. The vibration which is bisecting the 2B angle, whether that will be slow or that will be fast, we don't know this. Whether that will be slow or fast, we don't know. If that is known to us that the acute bisectrix is slow, then what is the use of determining optic sign? Got that? We are not known that this 2B bisectrix or acute angle bisectrix is slow or fast. If we know that, why we are using this interference figure, right? We have to find out whether that is slow or fast. That can be slow, that can be fast. Okay. For optic axis figure, that means, okay, for acute bisectrix figure, you are viewing a section like this. You are viewing a section like this where acute bisectrix is at the center of crosshair. For optic axis figure, one of the optic axis is at the center of crosshair, either this one or this one. Okay. If there is low 2B angle, if there is very less 2B acute angle, then only you can see the both of the optic axis, both of the melatope in the field of view. I will discuss that. Then obtuse bisectrix figure means you are watching a section like this, right? If this is the obtuse angle, this is the obtuse angle bisectrix, so you are watching a section like this. The obtuse bisectrix is at the center of crosshair. Optic normal figure or flash figure, that is optic plane is parallel to stage. Optic plane is parallel to stage. Off-centered figure is none of the above, is off-centered figure. Then talking about acute bisectrix figure, you can see here. You can see this is the these are the two optic axes, and I have already discussed in previous class that X and Z, X is minimum value, minimum refractive index, that is fastest vibration direction, Z is slowest, so highest refractive index, and intermediate is Y, and Y is perpendicular to XZ obviously because the coordinate systems are mutually perpendicular XYZ. And you can see the both of the optic axes, they are present in XZ plane. Both of the optic axis, they are present in XZ plane. Why? Because we are finding this is minimum, this is maximum, here there is medium, intermediate, then we are giving the circular section, we are taking the perpendicular. So all of the things we are doing in XZ plane only. All of the things we are doing in XZ plane only. So the optic plane is XZ in case of biaxial minor. So what will be optic normal? Y, right? XZ is optic plane, so optic normal will be Y. So you can see here, this is the 2B acute angle, this is the 2B acute angle that can be bisected by Z, that is slow vibration direction, or by X, that is fast vibration direction. If it is X, then that is negative. If that is Z, that is positive. So if you are taking acute bisectrix figure, that means you are cutting the section perpendicular to Z or X, right? So you can see here, because there are two optic axes, there are 2 points of zero retardation, right? Because there are two optic axes, one is like this, one is like this, so there are 2 points of zero retardation, which light ray will move parallel like this and like this. They will produce zero retardation here, named as melatope. You can see here, as we have discussed, it is not at the center of isogyre, not at the center of crosshair in acute bisectrix figure, and not the intersection of isogyre. Okay. So you can see these are the isogears. These are the isogears. These are the isogears. These are the two optic axes showing the position of melatope. And in each, for each melatope, there is there are isochromes. For each melatope, there are isochromes. Because I have already told you, when there is optic axis, when you are increasing the angle, there is production of circular rings of increasing order of interference color, right? So here there are two optic axes. This is for one optic axis. Here there are two optic axes. So what happens? Here they should produce circular isochromes. But what happens? There is two optic axes. While considering for this optic axis, if the isochromes they are moving outward, means the cones are moving outward. The isochromes are moving outward means the isochromer, moving through the outward isochromes. That means the angle of the cone is increasing. If this is the light ray, the angle of the cone is increasing, right? If this is the light ray, the angle of the cone is increasing. This is like this, right? So what happens if we are considering for this optic axis 1, melatope 1, we are considering for a light ray which is moving at some angle theta 1 to optic axis 1, that is also at an angle theta 2 to optic axis 2. Got that? If it is at an angle theta 1 to optic axis 1, so it is bent in circular manner. If there is no optic axis 2, the isochrome must be circular. If there is no second optic axis, the isochrome must be circular. Because there is another optic axis, what happens? It is also at an angle theta 2 to the second optic axis. So the effect of both the optic axis is on the light ray. Both the optic axis, they will affect the movement of light ray. So what happens? Iinstead of forming circular isochromes in around each melatope, they will form 8-shaped. They will form 8-shaped isochromes like this. The circular isochromes, they are not circular now. They are ellipsoidal, you can say, elliptical, you can say, or figure 8 shaped. Okay. Isochromes. That is due to effect of both the optic axis. When there is effect of both the optic axis, the light ray has a tendency to migrate within shortest path. Right? The light rays has the tendency to migrate in shortest path. So that will form a 8-shaped isochromes or elliptical isochromes. So the center of the isochromes, that is the position of melatope for optic axis. And what happens here? The isogear intersection is not the melatope. I have already told the isogear intersection is not the melatope. Here isogears are produced when X and Z, or X and Y, or Z and Y, that vibration matches with vibration of upper polarizer and lower polarizer. Got that? For uniaxial we are watching two vibrations, omega and epsilon. For biaxial, that depends upon section, which section you are taking, whether that is XZ or YZ or XY. There are three vibrations, XYZ. So that depends which section we are taking and which vibrations are there, whether that is X and Y or Y and Z or Z and X. That vibration when matches with the polarizer and analyzer, then there is position of darkness or extinction. Okay. So what happens here? When there is matching of vibration of both of them, then there will be extinction. Let's say, for example, I have already told these are the two melatopes. These are the two melatopes. If I will draw a line, that is showing you optic plane. That means XZ. This is showing XZ plane. So this is perpendicular to XZ plane. So what will be that? Y. That will be Y. So if you are considering at this point, there are two vibrations. One is Y or n beta. We have already discussed Y means n beta. In XZ plane, if Z is the bisectrix, if Z is the acute bisectrix, this vibration will be, if Z is the acute bisectrix, this vibration will be N alpha. Why? Light is vibrating parallel to Z. Z is at the crosshair. Z is at the crosshair. You can see Z is at the center of crosshair, right? So light ray is moving like this. Okay, you are finding one vibration. This is parallel to optic plane. You are finding this is one more vibration which is perpendicular to optic plane, right? You know that which is perpendicular to optic plane, that is N beta. Now the thing you have to find out, which vibration is this, which vibration is this, which is vibrating along the optic plane. If light is migrating through Z, then how it can be N gamma? Got that? If light is vibrating through Z, in the direction of Z, we are getting one is Y, another one will be X. So that will be N alpha. If X is the bisector, if X is the acute angle bisector, light is migrating parallel to X. So one will be N beta, that is fixed, perpendicular to optic axis or optic plane, perpendicular to optic plane, and this one will be N gamma, that is Z, parallel to Z, because light is moving parallel to X. Got that? If the acute angle bisectrix is Z, we are taking acute bisectrix figure, that means we are taking a section like this. So one of them will be vibrating perpendicular to optic plane, that is N beta. One of them will vibrate parallel to optic plane, that is N alpha, because we are taking Z as acute bisectrix. If X is the acute bisectrix, that vibration will be N gamma, that is Z vibration. Got that? You have to find out this thing, whether that is X or Z. If you know that acute bisectrix is X or Z, you know Minerally is positive or negative. Got that? You know which is perpendicular to optic plane, that is N beta, that is Y axis. Just you have to find out what is that vibration which is X or Z. If this vibration is X, acute bisectrix is Z. If this vibration is Z, acute bisectrix is, sorry, if this is Z, acute bisectrix is X. If this is X, acute bisectrix is Z. Then you know Minerally is positive or negative. Got that? So I will discuss that in determining optic sign, but now I have just discussed regarding these two, that if this is the optic plane, this will be Y vibration, this will be either X or Z depending upon Minerally is positive or negative. Okay. Then what happens, as I have told you, this is one vibration and this is one vibration. When these vibrations match with the polarizer and analyzer, there will be formation of isogyre. There will be formation of isogyre. If we rotate the stage, what happens? You can see at the center the vibration is mismatching. If we rotate the stage, the vibration is like that, along the optic plane, perpendicular to the optic plane, right? So the vibration is now mismatching with the polarizer and analyzer. So there will be formation of interference color instead of extinction. Isogyre is produced due to extinction, but here you can see there is no extinction because those are not parallel to the polarizer. So what happens? The isogyre shifts its position. The isogyre shifts its position in that direction where there is matching of vibration. Okay, the isogyre shifts its position in which direction there is matching of vibration. So that shape is of hyperbola. You can see that is a shape of hyperbola or H shape, right? The splitting of isogyre takes place in a hyperbola pattern, right? So if you have So you can find out the optic plane by that. Now moving to different types. This is for acute bisectrix figure. Then one more thing, when you are going to view both of the optic axis in acute bisectrix figure. In acute bisectrix figure, when you are going to view both the melatopes. Okay. See what happens when there is microscopic stage is here, microscopic stage is here. Acute bisectrix means acute bisectrix is at the center of crosshair, that may be Z or X. Now the optic axis can be like this, sorry. Okay, so this is the acute angle, right, between the optic axis. If it is, you can see at this position till this position, right? Here you can see the melatopes, here you can see the melatopes, or if they are in that position, you can see the melatope. If the angle is increased, you cannot see the melatopes. Got that? You can see both the melatopes in acute bisectrix figure if the angle is within some limit. Got that? Because this is my microscopic field of view, this is my microscopic field of view. If the angle is very small, you can see both the melatopes nearer to acute bisectrix. I am increasing the angle, you can view the melatopes. I am increasing, they are formed at the boundary. If I will increase further, they will not shown in the interference figure, acute bisectrix figure.
They will no longer be acute angle. They will form obtuse angle.
I am taking for example. What you have asked?
I am telling that if you increase the angle will become obtuse.
Okay, that is a limit, I will tell that. Okay, so when it will form at the boundary, when it will be formed at the boundary, that angle is 60 degree. That angle is 60 degree. Got that? Within 60 degree, you can watch the melatopes within the field of view. Right? If that is 30 degree, you can watch. If that is 40 degree, you can watch. If that is 50 degree, you can watch. 60 degree, you can watch at the boundary. If 70 to 89 degree or 85, 89, let's say 70 to 90. Within 70 to 90, you are watching acute bisectrix figure. When the 2B angle is 70 to 90, you are watching acute bisectrix figure without any melatope. If the angle is greater than 90, you are watching obtuse bisectrix figure. There are two figures like acute bisectrix, another one is obtuse bisectrix. So the acute bisectrix which is greater than 60 degree, which is greater than 60 degree, which is greater than 60 degree, and the obtuse bisectrix figure, they cannot contain the melatopes. Got that? Acute bisectrix figure with angle greater than 60 degree or obtuse bisectrix figure, both of them, they cannot contain the melatope. Got your answer? Within 60 degree only you can watch both of the melatopes in acute bisectrix figure. Got that? More than that you cannot see the melatopes. And obtuse bisectrix figures, that is general, that it will not show the melatopes because that is already greater than 90 degree. You cannot view more than 60 degree. Right? Then talking about optic axis figure, what happens in optic axis? One of the optic axis is at center. You can see one of the melatope that is at the center. The next melatope that can be within field of view if the angle is, I have told this total angle is 60 degree. This total angle is 60 degree. That means you are finding one melatope here in case of Bxa figure. That means acute bisectrix figure. So if you are taking optic axis figure, one melatope is at center. That means this part is omitted. Okay? You can view the next melatope within this much distance. That is 30 degree. That distance is showing 30 degree. If 2B is less than 30 degree, you can see both the melatope in case of optic axis figure. In case of acute bisectors, within 60 degree. In case of optic axis, that is within 30 degree. Okay. And you can see here, it is the Bxa. As I have told you, the matching of vibration is like this. The matching of vibration is like this here. This is Y or optic normal. This is optic parallel to optic plane. So that will show in extinction, which will represented as isogyre. Okay. Then talking about that position when there is only one melatope, when there is only one melatope, how to find out the position of next melatope. Okay, you can only see the melatope, you are not getting the Bxa in the field of view. Then how to find out the next position of melatope, whether the melatope will be here or the melatope will be here. How to get that? You can see that when you rotate the stage, I have already told, when you rotate the stage, that will form a hyperbola, and that hyperbola is away from other melatope. You can see if this is the melatope, this, if you are watching optic axis figure, for this optic axis, these isogyres, they bend outward from the direction of melatope. The second melatope is here. This is one melatope which we are watching here at the center. The next melatope is at here, and the isogyres, if I rotate the stage, the isogyres, they form hyperbola pattern which are away from the second melatope. Right? So you can see if this is forming like this, the isogyre is forming like this, the next melatope should be in this direction. If this is like this, here it is the melatope, the isogyre is like this, the next melatope is in this direction. Got that? One more thing, you can see the shape of isochromes. So how to find out that shape of isochrome? That is also helpful to differentiate between Bxa and Bxo, acute bisectors and obtuse bisectors. I have told you, in case of acute bisectors, if the angle is, in case of acute bisectors, is 2b is greater than 60 degree, you cannot see melatope. If in obtuse bisectors figure, that is greater than 90, so you cannot see melatope. It is always greater than 90, so you cannot see the melatope. So how to differentiate between Bxa and Bxo? Okay, see, if this is the melatope, this is melatope 1, this is melatope 2, this will be the Bxa, this will be the Bxa. The isochromes, they are forming like this. They are rounded towards opposite end and angular towards the next melatope. They are rounded towards opposite end and angular towards the next melatope. Okay, if you can study the pattern of isochromes, that means you can see in the field of view like this one. Okay, only this part you are watching in the microscope. So you can see the isochromes, they are angular in nature. The isochromes are angular in nature, so that is a Bxa figure. Both of the melatopes are absent in the field of view. Just see here, this is your field of view. Both of the melatopes, they are absent in the field of view, but you are watching angular isochromes. So that is your acute bisectors figure. But if you are watching circular isochromes or rounded isochromes, that means you are watching obtuse bisectors figure. Got that? You are watching obtuse bisectors if there is rounded isochromes or circular isochromes. If those are angular, then that is acute bisectors, because they are angular towards the next optic axis.
In this case, how to find the
These are not the isochromes, they are showing the indicators.
previous one? No. The previous case where we were considering the isogyre. To find
In this case,
how to find in this case? This B case.
B case, okay. How to find out?
The next melatope, second melatope.
If you rotate this one, this is not rotated. Not rotated, right? If you rotate, the next position is this. Rotate, second position is like this. So next is, so we have discussed regarding optic axis figure. Next one is obtuse axis figure. So what is obtuse axis figure? As I have told you, the obtuse bisectrix, that is at the center of crosshair. So you cannot view the melatopes. Here these are the isogyres showing extinction. And next is optic normal or flash figure. I am skipping this because these are not of many use. So optic normal and flash figure, just see the orientation. You can see the y-axis or the optic normal, which is perpendicular to the stage, that is at the center of crosshair. You can see that is written here optic normal. The y-axis or the optic normal, that is present at the center of crosshair. This is your acute bisectrix. This is obtuse bisectrix. Okay. You can see here these are the two optic axes, right? So it is perpendicular to optic plane. Then off-centered figure. You can see none of the above is off-centered figure. That means neither the Bxa nor Bxo nor the optic axis, nothing is at the center of crosshair. Nothing is at the center of crosshair. So that is off-centered figure. Then talking about determination of optic sign. This is important part. Determination of optic sign, that is same as uniaxial. It is same as uniaxial. You are using all the three accessory plates like gypsum, mica and quartz wedge. Same thing will happen. Same thing will happen.